how about we look at my version, or one possible version of the some answers for the gas law demonstration writing assignment. I made this window very small and unusual so as to hopefully focus your attention on just one part of the writing assignment at a time. For Boyle's law, we had this little black box with a syringe of air attached to it, and as we squeezed the syringe of air to a smaller space, we saw the pressure go up on the pressure sensor. The kinetic molecular theory explanation for that is, as we squeeze the volume to a smaller space, not letting any gas particles escape, not changing the temperature drastically, it forces the particles to collide more frequently. As the particles collide more frequently, then the pressure builds up. The force over a particular area increases. If we're just using P times V, P1 V1 equals P times V2 or something like that, you can use anything for pressure and anything for volume. But keep in mind, if you use PV equals nRT in the full-blown ideal gas or combined gas equation, then you have to use pressure in atmospheres and volume in liters. But if I'm just comparing relative V1 and V2, then they can be in any units you want. Avogadro's law, this is silly, I'm even ashamed to say I did it in class. I blew more air into an already partially inflated balloon. Of course, blowing more air increases the number of particles, N. So if you increase the number of gas particles, they start colliding. Mental blank. What happens to the particles? So they start colliding more frequently, and more frequent collisions results in larger volume, assuming the pressure stays the same. You might relate it back to PV equals nRT, but not necessarily. I said the number of gas particles in the sample must increase the volume so as to keep the pressure constant, not building the pressure, and the rate of collisions is about the same as measured or sampled by the temperature being about the same. Again, V and N can be actually in any units, as long as they're just V1 over N1 equals V2 over N2. As soon as you start to use PV equals nRT, then the gas constant R hints that volume should be in liters and N should be in moles. For Charles's law, we stuck, we just poured liquid nitrogen over a balloon, over a couple of balloons, and the balloon shrunk. Wow, that was surprising. Well, they shrunk because as the gas gets colder and the pressure and number of particles stay the same, the gas particles slow down. And as they slow down, they don't collide as frequently. And as they don't collide as frequently, the volume decreases, as long as the pressure outside the balloon stays the same. So we're always thinking about what the KMT, kinetic molecular theory. Oh yeah, I'm embarrassed I spelled the explanation wrong. Explanation. Anyways, I was saying with the kinetic molecular theory, we're always trying to think about what's happening to the molecules as they move around, how quickly they're moving around, how they're colliding, what kind of container they're in. And as above, volume can be in any units, but of course temperature needs to be in Kelvin in this equation. Unless you use PV equals nRT, then the volume has to be in liters. But as it is, volume can be V1 over T1 equals V2 over T2. Volume can be in any units as long as I know that V1 and V2 are in the same unit. Excuse me. And lastly, if the pressure and temperature are adjusted, like a metal sphere having a constant volume and constant amount of gas is heated or cooled, resulting in the pressure increasing or decreasing. And of course, as the temperature increases, the gas particles inside move faster. As they move faster, they collide more frequently. As they collide more frequently, they hit the walls of the container and anything in the container more often, which translates into greater forces and greater pressures. P can be in any units as long as I know P1 and P2 are in the same unit. Although if I were to go ahead and use PV equals nRT, then the R hints that P should be in atmospheres. 0.0821 liter atmosphere per mole Kelvin. But temperature has to be in Kelvin. Okay. Thanks. I'll see you in class or discussion. I'll also post this as a one-page PDF if you're really excited to get bored further. Thanks for watching, guys.